Hello, in this video we are going to look at an application of Pythagoras Theorem. So as you can see, we've got two right angled triangles joined to each other, and there's this unknown side x in each triangle. So let's just call this triangle 1 and this triangle 2. Let's check out triangle 1. So we know the hypotenuse is 10, we don't know this shorter side x, and we don't know this side here. So let's just call that side CA, side Y. So Pythagoras theorem is this, right? C squared equals A squared plus B squared. So if we were to substitute into this formula, we're going to have too many unknowns, right? In order to solve an equation, you can only have one unknown. Okay? Now let's check out triangle 2. So we have Y, the hypotenuse is unknown this time, and one of the shorter sides, and we know one of the sides. So again, too many unknowns. But when we have two triangles, we can form two equations and solve for two unknowns using simultaneous equations. That's a mouthful, but let's break it down. So checking out this triangle 1, let's just draw it first. Just draw it off to the side in a nice regular format. Now, so this side is x. This is our hypotenuse opposite the right angle. And this side is y. And then we may as well draw our other triangle. I'm just going to separate it. So our goal is to come up with two equations because we have two unknowns, and then we're going to solve simultaneously. So I'm just looking at this triangle CAD. This is x, 7, and y. Now, let's have a look. Let's form an equation. So we've got c squared equals a squared plus b squared for this first triangle. C squared, hypotenuse, squared is the sum of the shorter side lengths squared. So just substituting in. Now, we are going to rearrange for y. Our goal is to find x. We're going to rearrange for y in terms of x. Now, it will make sense soon. So let's have a look. 10 squared, let's simplify it, is 100, is x squared plus y squared. Let's make y the subject. So isolating y, I can put that x squared on the other side. It becomes take x squared. We're left with y squared. And I want y, not y squared. So I'm going to take the square root of both sides, and that's going to cancel that. I'm just going to rewrite the order. Y equals root 100 take x squared. So we have got an equation, okay? We're going to do the same thing for this triangle. We're going to form an equation and then rearrange for y. Then we're going to set them equal. It'll make sense soon. So start with Pythagoras. Substitute in your longest side this time is y squared. It was the shortest side over here. So 7 squared plus x squared. Simplify. 7 squared's 49. Now we want y on its own, okay? Now y on its own, we're going to take the square root of both sides, and that's going to cancel the square. So we're left with y equals root 49 plus x squared. Now, I want you to call this equation 1 and this equation 2. Now, we can actually set equation 1 equal to equation 2. Since they both equal y, right? They must equal each other. Y equals this and y equals this. Therefore, y equals y, and we're going to substitute in terms of x. So y is root 100 take x squared from equation 1. Y is root 49 plus x squared for equation 2. Now, looks scary, and if you get to this point, you might not know what to do. We are going to get rid of the square root sign on both sides, okay? How do we do that? We square both sides. Square cancels square root. So that gets rid of that. That gets rid of that. And we're just left with whatever's underneath the square root sign. And it looks a lot nicer. So 100 take x squared and 49 plus x squared. Now, put your x's on one side and your normal numbers on the other. So x is on this side and normal on this side. I'm choosing that because if I put the x's on this side, it's going to become positive. It's going to be nicer, okay? But you can do what you like. So over this side, x squared is there, and I want to bring this x squared over there. It becomes plus x squared. Over this side, the 100 stays. We want the normal numbers on this side. The 49 goes over to here. It becomes negative 49 because there's an invisible plus sign. If there's no sign at all. And then 100, let's simplify. 100 take 49, 51. X squared plus x squared. Well, there's invisible ones here. So 1x squared plus 1x squared, 2x squared. We're getting closer. Now we get rid of that 2 first. This squared is hugging the x. It's going to be removed last. So let's get rid of this 2. Whoops, just hit the microphone. Get this. Divide by 2. That cancels. 51 on 2. 25.5. We're getting closer. Is x squared. To isolate x on its own, taking the square root of both sides. Square root 25.5 is 5.05. And you'll just check how many decimal places they want the answer to. And what units? So I'm assuming 2 decimal places. And the units, because it's a side length, we're finding the value of x. It was centimeters. And that is your answer. So what did we do? We thought about it and we saw the right angles. Right angle triangles is always a clue to use Pythagoras Theorem. And then we looked at triangle 1 and we had too many unknowns, but we could still form an equation with some information. And then we looked at triangle 2. There was also 2 unknowns, so we could form another equation. And we rearranged for y in each equation, and then we set them equal to each other. Okay? So, and then we could just solve for x. So I hope that made sense, and I will see you in the next video, which is going to be this one. This diagram took me a long time to draw. Okay, you have a good day, and I'll see you in the next video.